Hello my friends, today I will be sharing with you a method with which you can prove that a triangle is isosceles. It's a general method which can be applied to solve many different kind of problems. But today I will be demonstrating it with a particular example. So, suppose we have this square ABCD with point M being the midpoint of BC. We form this line, and from point D we bring a perpendicular to AM which meets it at point E. We then form CE, and the question is, if DC is of known length, let's say 1 for example, we need to find the length of CE. So, first thing to do in this kind of problems is just to observe. Observe if an angle seems to be equal to some other angle, or if a line segment seems to be equal with some other line segment. So, if we observe carefully, we will notice that CE and CD seem to be equal. So, for me, the objective becomes to somehow prove that the blue triangle is isosceles. Now, I will show you the method. Suppose we have this triangle QSR and we want to prove that QS equals to QR. What we do is from point Q we bring an altitude to SR, and then somehow this somehow will depend on the information that you are given in each particular exercise, but the objective is to prove that this altitude is also a median to SR. If you manage to do that, then if you focus on the two small white triangles, you will have that line segment ST is equal to RT, then the angle STQ is equal to the angle RTQ, and segment TQ is common to both these triangles. Therefore, according to side-angle-side theorem, these two triangles will be equal, and so you will have that QS equal to QR. Alternatively, you could at first form the median and then somehow try to prove that it's also an altitude. And then you will again have that the same things as before, so QS will be equal to QR. Whether you choose to form the altitude for first or the median will depend on the particular exercise. In each case, you try to form whatever is more convenient for you. So, returning to our original problem, from point C we bring the altitude CF. We extend it until it meets AD at point G. Now, focusing on the two white lines, because ABCD is a square, these two lines are parallel. Now, if we observe the two blue lines, they are also parallel because the two alternate interior angles are equal. Therefore, the white quadrilateral will be a parallelogram, and so segment AG will be equal to MC. Now, because ABCD is a square, the two white lines are equal to each other. The line to the left is the sum of the blue and the green line, while the line to the right is the sum of the blue and the yellow line. We have already proven that the two blue lines are equal to each other, and from that we conclude that the green line is equal to the yellow line. Now, focusing on the white triangle, we have that point G is the midpoint of AD, and the blue line GF is parallel to AE. Therefore, according to a geometric theorem, point F must be the midpoint of DE. Therefore, for the blue triangle, we have proven that the altitude CF is also a median, and therefore CE will be equal to CD. So CE will be 1. This was the proof. Thank you for watching this video, and I will see you on the next one. Take care.